So those are three of the very basic classes of design. The 3+3 and the accelerated titration are very commonly used. Adaptive models have become more common, but they do require some more statistical involvement. So you might ask yourself, where did the idea for these types of stepping programs or stepped up or titrated designs come from? Let's look at a little bit of the theory process here. So it's starting with a low dose. If there are no ill effects, they're going to increase the dose. Then keep increasing until a dose is not tolerated by a predetermined proportion of the cohort. And from there, you back up to a prior tolerated dose level. So if you think back to the prior talk on trial designs and the video on the Fibonacci sequence, you can see where this 3+3 or this stepping came from. And that was sort of the idea generation for these escalated dose designs. So what about rule versus model? The differences in rule versus model. So 3+3 would be a rule-based acceleration. And model, of course, adaptive model designs are a modeling acceleration. So the starting cohort is going to be different. 3+3, it's designed for you. Accelerated titration, it could be 3, it could be a little lower. You could start with one person, 2 people, but ultimately you would default to a 3+3. And then the adaptive models, you'd have to have a sufficient number in the first time period to be able to run some modeling. So the starting cohort's different. The amount the dose is escalated will be different. And that's actually also going to be dependent upon the pharmacokinetics and dynamics and makeup of the medication or intervention that you're giving. Also, by the way, this could hold true for medical devices, particularly medical devices that are outputting medication. So if you think about something like a birth control device, or if you think about a pacemaker that's outputting an electronic pulse. So these types of studies apply to those situations as well. The differences between model and rule-based are the severity of tolerated toxicity and the number of adverse events that are allowed. How big is the next cohort size? What percentage that have to fail before you back up to the prior dose? And then the amount of de-escalation and by how much. So if you double the dose and you have a poor outcome across the board, would you back up and try half of what you had escalated to? So if it was 100 milligrams and you jumped to 200 and everyone failed, would you then go back to 150 and try that again? But again, that also depends upon how the medication is formulated. So you have to really keep those things in mind. How is this going to be administered? The basic difference is rule-based methods have predefined escalation and stopping rules. You will know before you start when you'll need to stop and how much you'll escalate. Model-based methods use statistical-based probabilities to determine the dose toxicity relationship. So you will have some kind of idea about your escalation, and you'll certainly know what a poor outcome is, but the proportion of people that have them and how many more people you'll use is going to be dependent upon the prior time period and the statistical models. So a little bit more complex, but may ultimately provide you a little bit more information or a clearer picture of where to go than a rule-based method. So when we talk about poor outcomes or moderate outcomes or toxicity, what do we mean by that in these early phase designs? So toxicity-based endpoints are easy to measure. So think about death, think about organ failure, think about a blood level that gets too high. So toxicity-based endpoints are much more clear. However, sometimes toxicity is not reversible, and you would not want to take every medication or every person up to full toxicity. And that's where this concept of DLT or dose-limiting toxicities comes in. These are toxicities that are theoretically reversible so that you could flush the system. So there is a medication for multiple sclerosis that's been associated with something called PML, which is a brain disorder. And if PML develops in a person that's been taking these medications, they basically flush the whole system through a series of transfusions and saline solutions. But there aren't necessarily totally irreversible effects of that. So you don't want to test all the way up to full toxicity. in humans. You certainly want to get as close as you can to an optimal dose, but with a dose-limiting toxicity. So there's a couple of things you want to be aware of. They can be irreversible and sometimes fatal. So if you think that the toxicity is a dose-limiting, but ultimately a participant or a patient might not be able to recover if you get into multi-system organ failure. Or there could be lasting effects that were not irreversible. But hopefully you find a dose that is, that the toxicity you can back down from. A common one would be, say, B-cell repletion. So how long does it take to recover from B-cell repletion? Now you have to be careful because you could overshoot the dose. So if you designed a 3+3 in this situation and every time period doubled the dose, you could overshoot and hit a toxicity-based dose level. So you need to be very careful about how you increase or escalate those doses. Non-toxicity endpoints could either be pharmacodynamic or pharmacokinetic related. What you really want to do is use a biological measure that is associated with a clinical endpoint before the clinical toxicity is observed. So you want to take it to the brink, but not more. If you're looking on planning these types of studies, the FDA has very strict rules, and you can go to the FDA website and look at guidances. This is the current guidance as of 2019. And that takes us through the trial designs for early phases. Up next, we'll look at the larger scale trial design.